All right, we're going to take some notes on parallel and perpendicular lines. You should have gotten these notes in class today. And so we're going to start with the outside. I'm just going to write some definitions, some things that you should already know. Parallel lines are lines that never cross each other. So I'm just going to write lines that don't cross. And then for perpendicular lines, we know those are lines that do cross, but they cross specifically at a 90-degree angle, or what we call a right angle. Okay, once you've written those definitions, then let's take a look at the inside. I'm going to start by finding slopes of AB and CD, and my hope is that they look like they're parallel lines to you, and we're going to find out why here in just a second. So I'm going to start at A, and I'm going to count up to B, up and then over. So I go 1, 2, 3, 4, and over 1, 2, 3. So my slope of AB is 4/3. Remember, slope is a ratio of a line's vertical change compared to its horizontal change. And so now I'm going to do the same thing with line CD. I'm going to actually start at D, though. I've got a little bit more room, so I'm going to count down 1, 2, 3, 4, and over 1, 2, 3. I went down 4, so that's negative, and I went left 3, which is negative. But we know that negative divided by negative is just a positive. So those slopes are actually the same. And if you think about continuing those slopes, because they're the same, those lines are never going to cross each other. So let's do the same thing over here. I'm going to start with E. If I count down 1 and then over 1, 2, 3, 4, I land on F, but I went down 1 and then I went to the right 4. So that's negative 1/4 is the slope of EF. And then I'm going to do the same thing for GH. I'm going to start at G and I'm going down 1 and then to the right 1, 2, 3, 4. So again, I have parallel lines, and you'll notice that the parallel lines have the exact same slope. So in this white space over here, I want you to write, excuse me, that parallel lines have the same slope but different y-intercepts. And that's important because if they had the same y-intercept and the same slope, they would actually be the same line. Okay? So parallel lines have the same slope but different y-intercepts. So now let's look at this bottom two graphs. And again, I'm going to start by finding slopes. Obviously, you can tell on these they're not parallel, and they are crossing. They are perpendicular lines. They're crossing at a 90-degree angle. So if I start at A, I count up 1, 2, 3, 4, 5, 6, and then to the right 2, and I land on B. So my vertical change was 2. I'm sorry, my vertical change was 6. My horizontal change was 2, and that simplifies down to just simply 3. And then let's do the same for line CD. Starting at C, I go down 1, and then go over 1, 2, 3, and I'm on D. So I went down 1 and to the right 3. And obviously this time those are not the same slope, but they do have a special relationship. So if I look at these two numbers, 3 and negative 1/3, if I take them and multiply them, so I'm going to multiply 3 times negative 1/3. Remember that 3 is over 1, and so we can cancel out the 3's, which leaves me with just negative 1. So it's kind of an interesting relationship that these slopes are going to have. Let's see if the same thing happens over here for E, F, and GH. So if I start on E and count up 1, and then count over 1, 2, 3, 4. The slope of EF is 1/4. And then the slope of GH, if I start with, let's see, I'll start at G and count down 1, 2, 3, 4, 5, 6, 7, 8. And then to the right 2. So I went down 8, I went to the right 2, and -8 divided by 2 is -4. So again, my slopes are not the same, but if I take 1/4 and I multiply by -4, which we can put over 1, I can cancel out the 4's. Don't forget that that negative is still there. And so my answer is -1. So again, when I multiplied the two slopes of these perpendicular lines, I got an answer of -1, which is kind of an interesting relationship that they're always going to have. So what I want you to write over here is perpendicular lines. And I'll show you the shortcut for writing perpendicular on Monday. Perpendicular lines have slopes that are what we call opposite reciprocals of each other. Opposite, let me see if I can spell that correctly. Sorry about that. Opposite, there we go. Reciprocals of each other. Opposite is going to mean that one of them will always be positive while the other one will always be negative. And then reciprocals, if you remember from maybe 5th or 6th grade, is fractions that are kind of the flip-flops of each other. So like 2/3 and 3/2 are reciprocals of each other. Remember that if you have an integer, it's over 1, and so its reciprocal will always have a 1 on top of it. So the other thing I want you to write here is that the products of their slopes, remember product means we're multiplying, is always going to be the same number, and that's -1, unless the lines are vertical and horizontal. Then we can't do the product, because remember, a vertical line has an undefined slope, and a horizontal line has a 0 slope, so we can't multiply those slopes together. Okay? I think I spelled everything correctly. Please forgive my handwriting, and bring these to notes with you to class on Monday, and we'll practice with some more with some parallel and perpendicular lines.